Yes, my name is Mike Sajdak, and today I will talk a bit about API security. And before I start, please navigate to this website, so securac.pl/q. No exploits, of course, here. And just please ask one question, then I will move to another question, and we'll have 3 questions in total. So, all right. So securac.pl/q. What is XXC? Here is the address for our little poll. All right, so let's show our results. Yeah, it's definitely a vulnerability in XML external entities. So, yeah, so let's go to another question. So what is SSRF? Or do you know what is SSRF? Maybe it's the same as XXC. All right. We have a bit more people now. Let's see our results. No, oh, it's interesting. It's server-side request forgery. I will talk about this a bit later during my presentation. And the last question is, what is Solar? I will also talk about this Solar a bit, so maybe it's worth knowing. So content management system, I don't know, search engine or a D-Link router maybe. All right. So let's see our results. Yes, it's definitely search engine. Okay, so thank you for using my poll, and let's go back to my presentation. All right, and a couple of words about me. I'm known in Poland from this website, securac.pl. I'm the founder of this little website about security. I also work in security company. We do penetration testing and trainings. It's something like 250 pen tests a year and about 100 different trainings a year. All right, what is API? Actually, I found this funny definition somewhere, so website made for computers. What is REST API? There are, of course, formal definitions, but actually I see that no one sticks to those or this formal definition, and the best definition, in my opinion, I found is this. So REST API is nothing more than just a web application, but this web application is structured. But the problem is that it is structured only in one company or only in one development team, so it's not widely structured. For example, one team is using post HTTP verb for updating, and another team is using post HTTP verb for adding new object using their API. All right, just two, maybe 3 examples. So one example from Facebook. As you can see, here is one parameter, another parameter, complex parameter, and it returns something. Another example from Google. So parameters everywhere here, actually. So I only have one hand, so I will zoom it a bit like this. So here parameter, here parameter, here parameters, JSON parameter, and here parameters. Parameters everywhere. It's not so structured, I'd say. All right, so let's see the first case about API hacking, and this is quite fresh from last month, actually. And in the United States, they have something like Location Smart. And as a demo, they allow you to track physical location of your phone. So basically, you put your phone number, your GSM number, into this website, and then they send you a short message, an SMS, you retype this SMS into this web form, and after this, so you authenticate this request, and after this, they show you the exact location of your phone. And someone exploited this demo stuff and was able to track location or to show location of every single cell phone in the US in real time. And the problem was in their API. So the website was pretty safe, pretty secure, but the API was a bit crazy. So he needed actually 2 requests. Here is our number, so your number or number of your victim. And here is another important thing, so this JSON. Because normally this API return information in XML. And when you use this XML version, this default version, this API was pretty secure. But after you change this to JSON, it allowed you to do something like this. So first request with this JSON and with this number, returned you token, so a random string, then another post request with this JSON, using this token, using this JSON, and without any authentication, it returned you the precise location of this number, something like this. So they had no authentication for this stuff, any number here. Right. So another case from last year in Italy, and in Italy you can buy a little box to your car, and if you drive safely, so this box monitors how you drive. If you drive safely, you have lower insurance rate. If you drive like insane person, you have your insurance rates going up. And someone analyzed this little box, and he extracted this little API request here. And actually, what do we have here? We have car license, so number from the license plate. We have domain, it was fixed. And we had company, so something like Allianz or ING, so insurance company. And without any authentication, it returned you all the history, locations. This is a template, but in real scenario, it returned you everything. And there's another code, which will be useful for a moment. So the first request. And the second request, we have still this hard-coded domain, company like Allianz, ING, something like this. This is another code, car license, of course, random data, and this UUID. And this UUID can be also extracted lower from here. So we have actually all the parameters needed, and in the response, we had all the information about the car owner, all the history, where this car was, actually everything. So no authentication and actually no authorization. All you needed was this actually number from the car plate. Pretty crazy. So another stuff from automotive industry, so this time electric Nissan. Someone analyzed this mobile application, and this mobile application normally communicates with this API here on the internet, and this API connects or communicates using GSM or internet to a specific car. So for example, you can turn on, turn off heating, check status of the battery and stuff like this. And it turned out that this mobile application sending this request, so this was Nissan something to do something like turn on heating, and the only thing which authenticated this request was this vehicle information number, which is printed, by the way, on a car. And it can be also iterated. So if your car has vehicle information number 101 at the end, another Nissan is 102, 103, 104, and so on, so on. So the guys did a little demo. So one was sitting in Australia, and another one was sitting in the UK. And the guy in Australia just turned on, turned off something in the UK, real time. All right, crazy vulnerability in WordPress. So in WordPress, in version 4.7.0, they introduced new REST API. And actually a bug, a vulnerability in this API allowed you to edit any post without any authentication. So what was the core of this vulnerability? So actually, if you want to edit this post with ID 1234, you can issue an HTTP post request to this URL and provide data, and this post is updated with this data. But alternatively, you can pass this ID twice. So this and this. And if you do this in the standard way, this is pretty secure, no vulnerability here. But if you put something like double ID here, let's see what happens. So for example, we want to edit this post with number 1 to 3. So we provide, after question mark, this 1 to 3 ABC. Then we have our permission checking function, and by default, it returns true. So if we have this post with ID 1 to 3 ABC, this post, of course, doesn't exist. And in this case, this function returns true. So you can update or edit this post with this non-existing ID. Nothing wrong. But the core of this problem is here on point 3. So just after the final update, they cast this value into integer. So we have rights to edit this 1 to 3 ABC, but now it is 1 to 3, and the post is edited. There were different botnets which exploited this vulnerability and published malware or something like this on many different WordPress sites. All right, another case, last year and Twitter, and actually this bug was worth 10,000 bucks, not bad. And actually the whole exploit is here on the screen, and the most important stuff is here, so doc type. Actually, this line is not necessary. I think that this guy just copied this from a tutorial or something like this. It's not necessary, actually. And he's defining here external entity. So the name of this entity is file. This is external entity, so this system keyword. And here you can provide a file from your server. So for example, if you want to read etc password from a server, you provide the file name here. One thing, definition of this entity, and another thing, we must use this entity. So amp, name of this entity, and semicolon. And in the response, when this entity was evaluated, we had etc password on the response. Right. Okay, a couple of words about HTTP verbs. So normally, concerning REST APIs, we use something like this. Get for getting data, post for adding or updating, put for adding or updating, delete for deleting. Sometimes you can find patch for updating and a couple of different methods. For example, on PayPal, you can use patch for update. And let's see to this case. Someone is actually grumbling a bit about his really tense corporate firewall. And this firewall allows only gets, so get HTTP verb, and post HTTP verb. No delete, no put. But they're needed for our normally functioning API. So what to do? And someone hints this guy that he can use this HTTP header, so X HTTP method override put. So basically, he can issue get or post request, but with this header, finally, put will be executed. And he says, okay, it works. So let's look at the case. Cisco Prime Infrastructure. I don't know if you are familiar with this product or no. Who knows this project? Please hands up. Okay, not too many people. Okay, let's see. They have an API which allows for something or for everything. And the first problem here is that Cisco's engineers thought that it would be nice to give access to documentation to all the users without any authentication. It makes sense, right? Documentation for everyone. But someone coded this stuff like this. So if you append this underscore docs parameter, so probably you want to access documentation, all the request is unauthenticated. But how to make another request than get requests? So this crazy header, HTTP method override post and post body. First step. The second step was with this get verb. It was not so easy to just put underscore docs on this get HTTP verb. And the idea to bypass authentication was to use this header, X HTTP method override, but with get lowercase. Why lowercase? I don't know, but it worked. And actually, the final step was this XXC, so bypassing authentication, another verb, doc type definition, using entity, and on our response we have etc password from the server. Actually, there is one more thing here in this case. Let me scroll back a bit. So as you can see, this API accepts normally JSON. And many people say, oh, we accept only JSONs, our APIs are using only JSONs, we don't care about XML vulnerabilities. But here we have this content type application JSON, and this guy completely removed this header, there is no content type here, and he somehow artificially put XML here. And this API accepted XML, and we exploited, or he exploited this XML vulnerability. All right, a couple of words about APIs discovery. So how to locate different APIs in your infrastructure. First, I would recommend looking into this site, crt.sh. Do you know this site or not? Who knows this? Not too many people. It's generally quite nice for web or also network reconnaissance. So basically, if you create an SSL certificate, it can be made for external or internal domain. This information goes most of the time automatically into a database which is called certificate transparency. And so domain, name of the company made this domain and made this certificate and so on and so on. And this crt.sh can be used to search this database. So basically, CRT. It works like this. So let's try Twitter, for example. Right. And as you can see, you will see different URLs like TD API, a couple of admin domains maybe, development domains, staging domains, something like this. Good stuff for reconnaissance. This is first thing. There are domains here, for example, something like Uber internal, for example. Let's try this one. Uber internal, it should be internal, but it's not completely internal, as you can see. And now you can just scroll through all the domains and check if any domain is available on the internet. I think you can try this stuff, crt.sh, on your own domain. Like VPNs, development sites here, and so on and so on. All right. So let's go back to my presentation. A little case with Uber. So at first, this guy located this backup Uber internal com. It is still visible on this crt.sh site. And then he made a little brute force, so brute force of directories, file names, and so on and so on. And finally, he found this SSO auth login response, which was accessible without an authentication. And it allowed for SAML communication. So he was able to use an XML, and he exploited XXC. So he was able to read files from the server. Another quite fresh case. All right, another case concerning using a known product. For example, if you use Liferay, it's content management system written in Java, there is a specific URL which is called /API/JSONWS, and it exposes you just their internal or just their API. So how to approach this stuff? At first, I will locate any Liferay website on the internet. So I will Google for this. It is in URL home something something something. This is specific part for LiveRay. I can also use here this com domain to narrow our search. There is something like agrofresh. Let's try this. This interface is automatically translated into Polish, and it requires me email, but I just don't care. I will just remove all this stuff. Maybe this stuff too, and now this API JSON-WS. And as you can see, we have this stuff with different functions. For example, I don't know, delete category. And we have all the parameters, and we can invoke. I won't do this, but in real, I don't know, pen tests, for example, or in a real attack, we can try this stuff. As you can see, many, many different functions. All right. So let's go back to my presentation. Okay, very nice case from last year. And actually, the Solar is the search engine, quite popular. Many big sites are using this, like Netflix or Instagram or SourceForge. Apple also, probably. And there was a little bug which allowed me with just simple search to execute any code on the target server. So let's look closer at this bug. So normally it works like this. For example, we have a shop or any other product, and it allows me for searching, and I can search here for something. This request goes to the Solar. Solar returns something. This is parsed here and presented to users. Normally, of course, I can't directly access the Solar. It listens only at or on localhost. So let's see the first step of our attack. The first step was like this. So if we provide this query string into something like this, it begins with this crazy specific string. So this stuff, exclamation mark, XML parser, and we can put an XML here, which is automatically parsed server side. And what are we doing here? Actually, you can't see any use of this, so there is no AMP, name of this entity, and semicolon, but we are defining here an external document type for this element A, and we are using this element A. So actually the server is forced to make an HTTP request to this site. Actually, I can show it to you on my Solar, and I have here very simple application. So I can just, maybe I'll zoom a bit. I can put something here, like star. Let's search for everything. This goes to Solar, and Solar returns me this stuff. Normally, this should be parsed and presented in a more nicer way, maybe, but we don't care here. And so let's try our first point. So let's force the server to issue an HTTP request. All right. I have here a virtual machine with my Solar, and I will log in just in a second, and I will start a netcat listening on port 4444, for example. All right, so netcat here is listening on port 4444, and now let's try to attack, or maybe let's try the first step of this attack. I have this query string here. It's exactly the same like on my presentation. And let's paste this stuff here. I will try to show you all this stuff on one screen. So let's resize this a bit. Here is our netcat listening. And now our solar is forced to make requests to the same machine, to the local host, port 4444. So here is our net card. Here I'm hitting enter. And now we have a request coming from localhost to localhost. User agent is Java, Solar is written in Java. So the first point works. So probably it will be vulnerable, but how to achieve remote code execution here? So let's go back to my presentation for a while. All right. And in default configuration, there is this API enabled listening on localhost, and it allows me to create a trigger. So basically, if something happens, like for example, event post commit, so someone updates something, and this trigger, so this code defined server side is executed. So I can put here everything, netcat, curl, wget, any code can be executed here. All right, and we have two problems here. The first problem is that we must know this collection name. The collection is basically a database in Solar. We don't know upfront what is the collection, what is the database name in our target Solar, but this can be quite easily solved because we can do another request. This request looks like this. So this XXC, normal get request to localhost, and we create new collection. Action create, name this pretty name, so we know already our collection name. All right, so let's go back to this. And the second problem is that we can theoretically call this API function or endpoint using XXC. It can be called from localhost. When it's called from localhost, it doesn't require any authentication. But as you maybe know, our XXC requests are GET requests. So this is only GET requests. How to convert this GET to POST. And there is a little trick in Solar, and it looks like this. So if Solar receives something, something, something with this short parameter, it automatically converts this GET to POST. And how to pass body, so post body to this GET request, there is a special parameter, stream body, and this body goes here. So actually calling this post API using XXC looks like this. And the last step will be to update our collection. So the first step, check if our Solar is vulnerable, then create a collection, create a trigger, this stuff, and update this collection. And just after or during this update, this code is executed. So let's try this. I will switch to my virtual machine. All right, I can close this stuff. Let's see if something is listening on 3333. This is something like, this. Connection refused, normal situation. And let's start our exploit. And our exploit just starts netcat listening on port 3333. So I already created this trigger, and the last point is to just update something from our database. So I'll just paste this link here. Still, we are changing only this query string. Pretty basic thing. All right, so let's try this. Now let's move to our virtual machine, try to connect here. Now it's open. We can issue actually any command. And it's executed, right? ID, something like this. So all you need is to have vulnerable Solar and use specifically crafted query strings. All right. So let's move to another case. All right, quite famous case of Equifax hacking. So actually, last year someone was able to steal data of almost 150 million United States consumers. It included something like 400,000 numbers, full numbers of credit cards. And actually what they exploited, and they exploited their API. And actually the exploit was pretty crazy because all the exploit was this XML. And the most important thing here in this XML is this small stuff. So this command to be executed. And now you may think, how actually this API executes this stuff? And the answer to this is that they are doing, the framework they are using is doing silent deserialization. And actually almost every deserialization, doesn't matter if it is Java native deserialization or PHP deserialization or deserialization in .NET, if you allow to deserialize something from users, almost for 100% you are vulnerable to remote code execution. And this was the case. And the same goes with Python, Java, .NET, PHP. And actually, if you want to see if your library or your framework is vulnerable to this, there's a little link here. This is for Java. This is for .NET. Just after the presentation, I will just show you how to download this presentation, so you can just use all the links interactively here. And if you're using, for example, Xstream, and this Equifax was using Struts framework, the Struts were using Xstream for the silent deserialization of XMLs, also JSONs, and so on, then it was vulnerable. And actually, till the late of 2017, everyone thought that .NET solutions are not vulnerable to this deserialization stuff. And then there was this really nice presentation on Black Hat, and they showed that actually issuing this pretty normally looking JSON allowed to execute this code in this proof of concept is just calculator running on the server. So another thing about deserialization, this time in .NET. There are readily available tools to produce such JSONs. All right. Talking about framework vulnerabilities, I have just one example from IoT world, and there was quite a big stuff happening in the late 2016. So someone was attacking or just rebooting or infecting almost 1 million German routers, and the case was like this. So many different manufacturers or producers had bought a generic firmware from a Chinese company, and actually this generic firmware was vulnerable to this stuff. So unauthenticated API request with this stuff, and this stuff was executed with full privileges on this target router. So actually they are downloading this backdoor here. It's one, then execution privileges, and they are starting this backdoor. All right, something about API key leaks. I have 2, maybe 3 cases here. The first interesting project, let's say, is not known as HTTP Archive, and basically they crawl using a normal web browser 1 million of most popular site according to a specific ranking, and they save all this information, so request headers, response headers, and maybe just a couple of more information into a big file. Very basic file is 5 gigabytes compressed. Full file is something like tens of gigabytes compressed. Decompressed, hundreds of gigabytes or a couple of terabytes. A bit of data. And someone actually is importing this big file into something which is called Google's BigQuery. And this Google BigQuery allows us to run any SQL query on a file which is uploaded, or we can upload this file by ourselves. So let's look how it looks. To do this, you need only any free Google account. And you can do something like this. Save queries. I have one query prepared. Let's run this new query. And this query actually asks about every URL which has this API key equal character in URL string. Alternatively, we could use something like this, and so on, so on. Let's stick with this stuff. Run query. All right, as you can see, you have many different API keys. And I think that at least some of them shouldn't be here. They should be treated as confidential information. By the way, you can use the same trick to extract stuff like this. So let's try this authorization header. All right. And as you can see, you can locate different authorization basic headers, which are basically usernames and passwords, base64 encoded. So let's decode this first one. Base64 decoder, and as you can see, they're using user hits1_u and very complicated password hits1_u pwd. Another interesting thing, maybe let's stay with this very basic demo about this. All right, so another case. Okay, this guy is complaining that someone stole him $100 and he was preparing scripts for automating Bitcoin trading, and he asks the other guys, what's up with this problem? Where are my $100? And someone says, okay, I found the issue. You committed your code with your API key to your account to a public repository, and someone just extracted this API key from this repository and used this to transfer the money to his account. And he said, okay, now I have this fixed. And if we click to this code, now we can see that they have this stuff, and this is passed from arguments to the script. But we have something like history here. Yeah. And if we click here, we can see down here that there is this API key and API secret. So hopefully this guy changed those values. All right, and maybe one more thing about this stuff. Another complains that, okay, but I have two-factor authentication enabled to my account, so how the heck he was able to steal my money? And they answer him, okay, but usually APIs just bypass two-factor authentication, so we don't want to retype in every single request to any function our code which is coming to our cell phone, for example. So this is another thing to remember. Calling API usually bypasses two-factor authentication. All right, actually, this is almost everything. I have one more thing prepared for you. Unfortunately, it's only in Polish, but in near future, it will be also in English. So my little book about JSON Web Token security. It's quite complex. And I think that I will upload this presentation to folks from Confidence, so they will upload this to their official site. If you want to have this earlier, just mail me from your email. And if you want to know a bit more about APIs, I also run a training about REST APIs security in Polish and also in English. Okay, any questions from you? All right, I can't see any questions, so thanks for listening.